Hello everyone, this is the first lecture on random variables. In this video, we define random variables and types of random variables. Let us consider a random experiment and let omega be a sample space. Let us set up all possible outcome of the experiment. A random variable x is a function from sample space omega to real numbers. That is, a random variable x assigns to each and every element in a sample space a unique real number. For instance, if I consider the sample space has only two elements, okay, three elements, S1, S2, and S3, and X be a map from sample space to real numbers. Let me write it as omega as S1, S2, S3, X be a map from these two real numbers. Okay, for instance, we assume that x1 s1 is mapped to r1 real number r1, and s2 is also mapped to real number r2, and s3 is mapped to r2, and we write it as this: x of s1 is equal to r1, x of s2 is equal to r2, and x of s3 is equal to x of s2 is r1, x of s3 is r2. And it's clear that image of omega under x has only two elements. One is r1, other one is r2. Therefore, we can say that random variable x has two elements. We write it as something like this: r1, r2. Now let us consider an example. Toss a coin 3 times. All the possible outcomes of this experiment is written here. It has 8 possible outcomes. The first one is headed head, then headed tail, and so on. Let suppose that last outcome be tail tail tail. Let me consider this map. Let me write all the outcomes explicitly here: headed head, headed tail, head tail head, tail head head, tail tail head, head tail tail, tail head tail, and tail tail tail. Okay, and they are given that x is a random variable which denote number of tails. What we do is we define a map from omega to real numbers. Define something like this. Since x is a random variable which denote number of tails, let me assign a real number 0 to headed head, because headed head has no tail. And second outcome, headed tail has one tail. Let me assign 1 to headed tail. And also our third and fourth outcome also has one tail. Let me assign 1 to these outcomes as well. Okay, and similarly this will be mapped to 2, and this final outcome will be mapped to 3. From this we can say that this random variable has 4 elements: 1, 2, 3, okay, 0, 1, 2, 1, 3, because the image of omega under this map has only 4 elements, and we call this as random variables. Okay, let me consider one more example. Let me consider a sample space. Let this be a set of all students in a university, or a set of all students in a city, or set of all people in a city. And h be a random variable which define height of students. Okay, in this particular case I mentioned students here, and w denote weight of students. Suppose that S1 be one of the student whose height is 1.575 meter, and let its weight be 70 kg. Okay, that will be too much. Okay, no problem. 71.34 kg. Okay, and so on. Now we can explicitly find height and weight of each and every student, and we can list it out. And suppose if you assume that there is no student whose height is less than 1.5 meter and more than 2 meters, then we can say that The random variable h is uh, sort of all those elements that lie between 1.5 and 2 meters. And W be a weight of students. Assume that minimum weight of student is 40 and maximum weight of students, sorry, if students be 90, then we can say that this W lie between 40 and 90. Because whenever we use random variable to denote every element inside this random variable, we use lowercase letter, corresponding lowercase letter. If W is a random variable, and to denote elements inside the random variable, we use lowercase w. That's a notation. Now we got two random variables for the same sample space. Now we define one more as well. Look at this. Let me find body mass index of each and every student. What's the formula to find body mass index? That is weight divided by height square. Okay, in this way I can find body mass index of S1, the student, which is 71.34 divided by 1.57 phi square. Now what I'm trying to say here is we observe two important things here. One is we can define more than one random variables on a sample space. We can define more than one random variable on a sample space. And second one is function of random variable is again a random variable, because W is a random variable, H is a random variable, and B is function of both W and H. As we can say, a function of random variables is again a random variable. And another two important thing to observe from this example 1 and 2. Look at this. In example 1, look at it. It has 4 elements. Now all the 4 elements are okay. It has finite number of elements and it's countable. It's an integer. Okay, whenever a set is integer, or a subset of integer, or anything which is equivalent to integers, then we say that the set is countable. In this example, it is not countable. Why? Because assume that we are trying to measure weight and height as accurately as possible. If that is the case, then height can be anything between 1.5 and 2 meters. That is, it can be anything with 4 decimals, 5 decimals. Then we can say that this is uncountable, because those elements cannot be equivalent to integers. Thus, we can say that we have two types of random variable. One is a random variable which has a countable number of elements. Other one is a random variable which has uncountable number of elements. We call this discrete and continuous, respectively. Okay, a random variable that assumes a countable number of possible values is said to be discrete, and continuous if random variable takes uncountable possible values. That's it. Thank you.